Okay, so this is now part 3 of our video lecture here. So now on part 3, we're going to be working on question 2. So you're told that now imagine that researchers think that gender may interact with the isolation variable we analyzed in class. To determine if there was an interaction between isolation and gender, you will need to run a new statistical test. For this question, carefully code gender as follows. In SPSS, you should be able to see that all rows are numbered and that each row represents a participant, right? So we already know that. I want you to enter in 0 for all female participants and 1 for all male participants. All odd rows assume to be female participants, and all even rows assume to be male participants. So 1 is an odd row, right? So that's going to be a 0. And an even row is row 2. So that's going to be a 1. And we're just going to go through it. So 0, 1, 0, 1, 0, 1, 0, 1. Okay? Looks right. So you can duplicate this by saying Control C, Control V, Control V, Control V, Control V, and Control V. That will only work for you if you're on Windows. So the other thing we haven't done is we haven't named this variable. So we need to do that now, right? So we're going to go into the variable view down here, and we're going to click on the name, and we're going to write it as gender, and we've just done that. We're also going to take away the decimals. We don't need decimals for this variable. We can label this as gender just so when we produce the graph, it looks better. And then if we go to values, just like before with the other independent variable, we want to do this again. So if we have a value of 0, we want to label that as female. If we have a value of 1, we want to label that as male. Okay, and we have to hit add each time and hit OK. And then the other thing is we know this isn't a scale variable. We also know it's not an ordinal variable because it doesn't make sense that males or females would be higher or lower on some ordinal scale here. So it's nominal. That is, we assigned numbers that don't have any meaning to these categories just so the computer can tell them apart. So then we go back to our data view, and we can see that it looks good. And so we want to do an ANOVA test to be able to tell or to test our null hypothesis here. And so because we have 2 independent variables, we're going to want to do a 2-way ANOVA, right? And notice this is a lot like everybody's project. You have 2 independent variables and 1 primary dependent variable. And so this should be directly applicable for when you're analyzing your data for your papers. So again, go to Analyze. This time you actually have to go to General Linear Model. This is where you're going to actually build the 2-way ANOVA, okay? So that sounds complicated, but it's really easy. We're just going to click on Univariate, which means we have 1 dependent variable. Click on it and put our 1 dependent variable into the 1 dependent variable box, and then put your independent variables into the fixed factors, okay? In model, don't worry about it, just hit cancel. For contrasts, don't worry about that either, just hit cancel. For plots, this is how we're actually going to build the graph. I want you to put condition on the horizontal x-axis so it looks like the graph we made for question 1. But then I also want you to put gender as separate lines on the plot. So what this will do is it'll plot males and females for us on separate lines. So instead of having 1, we'll have 2 lines. And then we click add. And then I want you to say include error bars. And that's all you have to do. So hit continue. Post hoc tests, remember this is like the Tukey test that we did before. So bring both of your independent variables over and put Tukey and hit OK or continue. Estimated marginal means. This will also compare differences between levels. Specifically for interactions, this is really good. So we can do that here. We can compare gender and the condition for a potential interaction, and we'll say continue. Then click on save. We don't need to click on any of these things. This will give us different values. This is more helpful if we're doing something like a regression. So hit cancel and go to options. In options, I want you to pull descriptive statistics estimates on effect size, and observed power. Okay, so descriptive statistics again are like your mean and standard deviation. Estimates on effect size are a slightly different thing. That'll tell us how large the effect is. So p-values tell you whether it's significant. Estimates of effect size try to analyze the size of the significance. So it's a little different, but it's important. Observed power, this is something I talked specifically about earlier in class. This is the percent chance that you find a true effect. Okay, so the percent chance that your test finds a true effect or is able to reject the null hypothesis, assuming the null hypothesis is false. Okay, so that would be like if you're trying to figure out if men are taller than women. That's something that on average is true in the general population. And this statistic, if you did a test to see if that was true, would tell you the likelihood that your test is able to find that result. And I told you in class that we want this to be at least 80%. So we're going to see what our observed power is. So click continue and hit OK. And just like before, SPSS is going to spit us out new numbers. I want you to copy and paste these into your document. I've already done that for you here, so it's down here. So I copied in isolation and the groups and gender. I copied in the between subjects effect. This is your ANOVA report. And you can see here, you don't want to look at the intercept or the corrected value. Ignore those numbers. If you look at condition, this isn't significant. And our gender variable isn't significant. Again, it's not below 0.05. And our interaction isn't anywhere close to being significant. So, again, we were not able to reject the null hypothesis. This is that estimated marginal mean we found. So it's looking at the estimated means when you combine condition with gender. I want you to copy in your graph here. It should look nice. If it doesn't look like you put in the variables correctly, if you didn't label them, you won't get full points. So make sure you do label your variables. Okay, so again, copy and paste those into the document. And then the other thing I want you to do is try to generate a dichotomous median split for, or mean split for extra credit, okay? So I'm going to show you how to do that really, really quickly here, okay? So there are some groups that have a dependent variable that they want to be able to split in half on a high-low split. So let's say they were trying to measure people's anxiety between men and women, and they wanted to dichotomize or split the dependent variable, okay, into two pieces to make it a categorical, qualitative, independent variable, okay? So it sounds like a lot, but for the groups where that is necessary, you should know who you are, and this might help you, okay? So the first thing we need to do is figure out where the mean is if we want to create a high-low split. So we want to look at the mean of everybody, okay? And so let's see here. So my mean is 7.33, okay? So if you type in your numbers slightly different, it's not the end of the world. Just enter in your split based on your mean. So what I'm going to do is, and this is where you create a new variable, because we want to create a new variable from this variable where we create a low and high split. So you go into transform and recode into different variables. Not same, because that'll overwrite your old variable. Recode into different. Grab the variable that you want to recode, which is utilitarian decisions. Make a new name for it. So maybe say utilitarian split. And we'll say it's a utilitarian decisions mean split. Okay, so this can't have spaces because it's a name, but the label here can, so hit change. It's very important that you hit change. And then you go into old new values. And we want to say that any values, the lowest value through a certain number are going to equal a number. Okay, so we want to say that the lowest value So 0 to 7.32, we are going to recode as a 0. So anybody that made from 0 to 7.32 utilitarian decisions on this new variable will be classified as a 0. Then, because we want to make a high-low split, anybody that made 7.33 utilitarian decisions up to our highest number, which is 20, we will now classify as a 1. And we click Add, and we hit Continue, and we hit OK. And if you go back into your data view, you'll see a new variable. And it looks correct, right? 16 was classified as a 1. Somebody had 4 utilitarian decisions. They were classified as 0. And all I want you to do is to get the mean of that variable. So just go in to Descriptive Statistics, click Descriptives, and click on your new variable, bring it over, and hit OK. And you can just do that, and that will work for me. Okay, and you can copy and paste that in here. Don't worry about this thing I got you. Just copy and paste this in. Okay, and that will work because I'll be able to see the maximum value and the minimum value. Okay, and if you copy this in, you'll get 2 extra credit points. Okay, so if you have any questions about the assignment, let me know. And also, don't forget to make a conclusion about the null hypothesis, okay, for full points. If you have any questions, let me know over email. Stay safe out there, everyone. I hope things go well through the rest of the semester, okay? All right. Thank you so much.